Hi everybody, welcome to chapter 11. So this chapter is about rational expressions, which is basically fractions with algebra in them. A lot of you have expressed your opinion about fractions. I hope this isn't too bad though. Anyway, for this video we're going to do 11.2 to 11.5, and then the homework is 7 through 13. Mr. Wonder claims that anything divided by itself equals 1, as long as you do not divide by 0. Mr. Wonder states that 16x divided by 16x equals 1 if x is not 0. A. Is Mr. Wonder correct? Justify your conclusion. Okay. So the question is 16x over 16x equals 1. Is that correct if x is not equal to 0? Okay, well, this is definitely correct. One of the ways you can justify your conclusion is by plugging a number in. So, for example, I could do x equals 1, which is super simple. 16 times 1 over 16 times 1 equals 1. And that's true. 16 over 16 equals 1. You've also seen this, I'm sure, and this is probably the only time I'm going to draw this guy. If you remember him, this is called the giant one. And the reason it's called a giant one is because it's a fraction which is equivalent to 1. So the great part about it is I can multiply by it and I will not change the value. Okay. B. Why can x not equal to 0? Okay, so hopefully you guys know this. Cannot divide by 0, and 16, if x was 0, 16 times 0 would be 0. Okay, if you don't believe me, believe the calculator. I know you guys will believe technology. 16 times 0, I'm just plugging 0 in for x, divided by 16 times 0. Nope, calculator won't do it. So you have a containing division by 0, the calculation fails. Okay, C. Next, Mr. Wonder considers x minus 3 over x minus 3. Does this expression equal 1? What value of x must be excluded in this fraction? Okay, so does this equal 1? Well, let's pretend that x is 1. We would have 1 minus 3 over 1 minus 3, which would be negative 2 over negative 2. Is this a giant 1? Yes, it is. Okay, we're not going to do this every time. When we get further on here, what we're going to do is end up canceling those. But yes, this does equal 1. And what value of x must be excluded? Okay, so what we want to do is look at the denominator only. So this is the part I'm interested in because I cannot divide by 0. I can't have 0 in the bottom. 0 on the top's okay. 0 on the bottom's not okay. Okay, so what value would make this 0? And the answer is 3. X cannot equal 3. Sometimes you have complicated things in the bottom and you can't tell what they would be. So off to the side, what you want to do is some extra work. X minus 3 cannot equal 0. Add 3 to both sides. X cannot equal 3. A lot of times though you can just eyeball and say, okay, 3 minus 3 would be 0. D. Create your own rational expression that equals 1. Be sure to state any exclusions. Okay, so you guys can do any one that you want, but my favorite number is 7. Well, that's not true. My favorite number is 4. Hank's favorite number is 7. So what about x plus 7 over x plus 7? Or 7x over 7x? Or 7 over x over 7 over x? Those all equal 1. Okay, E. Mr. Wonder says that when any fraction or number is multiplied by 1, the fraction stays the same. For example, he says the product below equals x over y. Is he correct? Okay, so I have this picture. Hold on, let me draw this first. My giant ones are awful. I'm really sorry. Okay, so this is the question that we're asking. And yes, this is true. If I multiply by 1, it stays the same. And let me show you what would happen. So if I multiplied across the top, multiplied across the bottom, and then canceled out the z's, I would have x over y. Okay, was that really necessary? No, you can just tell that that's 1, so x over y times 1 is x over y. Oh man, I have to go back to D. I forgot to state the value that would be excluded in these. Okay, so in this one, x cannot equal -7. -7 plus 7 would be 0. In this one, x cannot equal 0. And in this one, x cannot equal 0. Because you can't have 0 in the denominator. And 7 times 0 is 0. And 0 is 0. Okay, what about this one? Well, looking at this, you could not have y could not equal 0 and z could not equal 0 because z and y are both in the bottom at this point. Okay. 11.3. Use what you know about the number 1 to rewrite each expression below in an equivalent, simpler form. State any value of the variable that needs to be excluded. Okay. Alright. A x squared over x squared. Okay. The top and the bottom are exactly the same. So this is 1. And x squared cannot equal 0. This is from the bottom x squared. Square root both sides. X cannot equal 0. You do not need to do this work. A lot of times you can just tell x cannot be 0. You don't have to set that up. I'm just trying to be helpful. Okay. B. X over x times x over x times x over 3. Okay, there's a few ways to do this problem. Hopefully you guys can tell that is 1 and that is 1, so I have 1 times x over 3, which is x over 3. Okay, and what can x not equal? X cannot equal 0 in this one. X cannot equal 0 in this one, and that one doesn't count because it's definitely 3 and it's not going to be 0. Okay, C. X minus 2 over x minus 2 times x plus 5 over x minus 1. Okay, hopefully you guys are able to see that that is 1. some of you guys out there are going to start skipping this step, and that's totally fine, because you can see that that's 1, and 1 times anything is itself. Okay, that's not the interesting part about this problem. The interesting part about this problem is the exclusions. So in this particular case, if the problem started, I have 2 different denominators. I have x equals x minus 2 and x minus 1. In this denominator, x cannot equal 2. And in this denominator, x cannot equal 1. And you have to list both of them. So the key here is the exclusions come from the problem, not the answer. The problem says x cannot be 2, x cannot be 1. But the answer only says x cannot be 1. But you will get it wrong if you don't list both of them from the actual original problem. Okay, D. 9 over x times x over 9. Okay, well that's not 1, and that's not 1. So I'm going to multiply across the top, multiply across the bottom. Oh, and now they're the same, so that equals 1. Okay, and what can x not equal? It's just x on the bottom, so x cannot equal 0. You have to put commas here so that it separates it from your answer from the algebra. I just did D. This is E. Okay, E. H times K over H. Okay. Do you notice that there is a 1 here? This H and this H make a 1. And what I can start to do is cancel like this. That creates a giant 1. Answer is HK. Okay. What values are excluded? H is in the denominator, so H cannot equal 0. Okay. 2m minus 5 m plus 6 over m plus 6 3m plus 1. Okay, this is a great problem. First thing I want you to notice is that these are factored, which would be the result of diamond and box mostly. So if any of you are looking down the road at what's coming, diamond and box is coming. Okay, can you tell that m plus 6 and m plus 6 make a giant 1, so they can be canceled? 2m minus 5 over 3m plus 1. Okay, now what values are excluded? Again, we have to look at the previous problem, not the answer. So in this one, even though it's canceled out, m cannot equal negative 6. This one's harder to tell. Some of you guys are screaming the answer out there, but for some of us, we can't really look at that and just say, oh, x cannot be, or m cannot be, whatever. Okay, so what I ask you to do in this case, if you can't readily just see it, write 3m plus 1 cannot equal 0. 3m cannot equal negative 1, so minus 1 from both sides, and then divide by 3. M cannot equal negative 1/3. Okay. Alright, we have, this is a long problem, G and H to do still. Okay, 6 n minus 2 squared over 3 n minus 2. Okay, you'll get to the point where you can cancel one of the n minus 2's off the top with the bottom, but for now, I'm going to write it out because it's our first one like this. So there's my 6n minus 2 squared, 3n minus 2. Hopefully this will make it a little easier for you to see. And then after this, you can just cancel out the bottom and one of the top ones. N minus 2's make a giant 1. Okay, and I have 6 n minus 2 over 3, and then you can take the constants, this leading coefficient and the 3, and divide those to n minus 2. And you can leave it like that. You don't need to distribute. Okay, so going back to the original problem, what can n not be? The 3 doesn't matter because that's a constant. It's not 0, so that's not a problem. You want to say n minus 2 cannot equal 0, n cannot equal 2. Okay, last one for this problem. Three minus 2x over 4x minus 1, 3 minus 2x. Okay, hopefully you notice that those two make a giant 1, and this is really important. I went all the way to h to get to this part, but I want you guys to see that if I cancel this, this is a 1, so I have 1 over 4x minus 1. This is a giant 1. 4x minus 1 is on the bottom, so there's still a 1 on top. Okay, and that's as far as you can go. That's the answer, other than the exclusions. So I have 4x minus 1 cannot equal 0. 3 minus 2x cannot equal 0. 4x cannot equal 1. X cannot equal 1/4. And negative 2x cannot equal negative 3. X cannot equal 3 halves. Okay. Okay. Number 4. Mr. Wonder now tries to simplify 4x over x and 4 plus x over x. A. Mr. Wonder thinks that since x over x equals 1, then 4x over x equals 4. Is he correct? Substitute 3 values of x into the original expression to justify your answer. Okay, we're only going to do 1, because you guys will be able to see it right away. So this is the question we're asking, is 4x over x 4? Okay, so we are going to plug in 1 and see what happens. 4 times 1 over 1 equals 4 over 1 equals 4. Yep. Okay, so when you have something like this, you can cancel out those x's and just have 4 left over. Okay, on the other hand, for B, he also wonders if 4 plus x over x equals 5. Okay, where is he getting that? Well, he's thinking that this is 1, so 4 plus 1 is 5. Some of you might think that this is 4. You can just cross that out and it's just 4. Truth is, it's neither of those. Okay, so let's see what happens when we plug in a 1. So we have 4 plus 1 over 1 equals 5. Oh, Miss Hyde, you're totally wrong. Okay, this is a special case, which is why they asked us to plug in 3 values. Okay, so let's try this. Okay, so what's 4 plus 2? 6 over 2 equals 3. That is certainly not 5. Okay, which means that this is not a giant 1. this is not a giant 1, this is not a giant 1. And the reason it makes it not a giant 1 is the addition symbol. So if you have addition and subtraction, you cannot just cancel those out. So this is a no, and this is a yes. This one is all multiplication. This one has addition in it. So that is the difference. Okay. Oh, we just did C. Alright. D. Which of the following expressions below is written correctly? Explain how you know. Okay. So we have two different ones, and we're going to see which one is correct. X squared plus x plus 3 over x plus 3 equals x squared. Or is it this one? X plus 2, x plus 3 over x plus 3 equals x plus 2. Okay, so Miss Heidi said you can't just cross out when there's addition. That's true. This one has addition in it though. However, this is a number, this is a number, and this is a number, which are being multiplied. So if it's hard for you to tell, what you need to know is that it needs to be in factored form before you can cancel anything out. Let's practice this with x equals 1. So I have 1 squared plus 1 plus 3 over 1 plus 3. And if this was equal, if I could just cancel that and cancel that, then that would be equivalent to 1 squared. Okay, so the top would be 1 plus 1 plus 3, which is 5, over 1 plus 3 is 4. Okay, that is not equal, which means that you cannot cancel that and you cannot cancel that. That is not cancelable. Okay, now in this one, okay, so I'm plugging 1 in to all of the x's to see if it's equal. I have 3 times 4 over 4 equals 3. 12 over 4 equals 3. Yes, okay. So factored form. We want it to be in factored form before we think about making giant ones. Okay, last problem. And this is kind of momentous because some of you guys won't care, but some of you will. I have been using the same notebook since the beginning of the year. Here's the first lesson we did. And now I have come to the last page. But I'm prepared. I have a new one right here. Okay. And your class is going to the blue. Okay, last problem. 11-5. Okay, so we are going to simplify these properly, and we are going to state excluded values. Okay. Okay. So, what I want to make sure that you know is that you can't cross this out. You can't cross that out. Because this is not factored. You have to factor it first. and you have to factor the top and bottom separately. The top is a trinomial, which means that I'm going to factor it using diamond and box. Okay, x squared goes in the first box, 9 goes in the last box. Multiply those two, 9x squared, 6x in the bottom, 3x, 3x. Okay. Okay. The bottom is a difference of squares. Okay, so notice it's a difference. X squared is a perfect square and 9 is a perfect square. Okay, just to remind you from Math 2, what you do for a difference of squares problem is you take the square root of the term in the front, so x squared square rooted is x, or you can think of it as x times x, 3 times 3. And to make this subtraction, you need to have one of them be positive and one of them be negative. Okay. Now I can see that I have a giant 1 here of x plus 3. Okay. And my final answer is x plus 3 over x minus 3. Okay. Now it says in the problem, assume the denominator is not equal to 0, but I just want to mention for this problem you had two factors on the bottom in the denominator, this factor and this factor, and both of those will give you exclusions. So in this case x cannot equal negative 3 and x cannot equal 3. Okay. B. Okay, so this one is very similar to the previous one. I have a trinomial on the top and a trinomial on the bottom, which means that I'm going to do diamond and box for both separately. So I'll start with the numerator. Two x squared negative 10 negative 20x squared negative x negative 5x 4x 2x x minus 5 2. Okay, that's my numerator. Okay, now I'm going to do my denominator separately. Okay, that's x plus 2. I was going to say, usually with these there's one that is in common to both so that you can cross it out. Unless the book was trying to be tricky, sometimes there aren't any to cross out, but this is our first lesson on this, so I figured they were not trying to be tricky. I forgot this was plus 2. Okay, so I have my giant 1 here. 2x minus 5 over 3x plus 1. Okay, exclusion here would be negative 1/3. Exclusion here would be negative 2. The book didn't ask us to do that, but I'm just still working on that. Okay, now C is my favorite problem because it looks terrible. Okay, and you're like, oh my god, I do not want to factor that. I do not want a dime in a box. It looks terrible. Those numbers are awful. Okay, what do you notice? Oh, whatever the top factors into is going to be the same as whatever the bottom factors into. Don't do this all out. It's just 1. D. Okay, now this is a great problem too. It is, both of these are either 2-box or greatest common factor. Okay, so what I want you to do is take a look at these and notice what can I take out of them. Notice they're not trinomials. They're also not difference of squares. So how can I factor this when I don't have a constant here and I don't have an x squared there? Okay, what I'm going to do just for this time is a 2-box for both, and then I'm going to do greatest common factor after that, so you don't have to show this work every time. But okay, what do these have in common? X. So x times x is x squared. X times 4 is 4x. Okay, so the top would be x plus 4. Again, you do not need to show this work. You can if it helps you, but for a lot of us, we can tell that there's an x in both of them that can be brought to the front, factored out, and that x plus 4 would be remaining. Okay, last thing. Let's practice this again. 2x, 8. What do they have in common? 2. 2 times x and 2 times 4. So I have 2x plus 4. Okay, so notice they both have 2 in common. That can be factored out. And just check yourself. Is this x squared? 4x? Yes. 2x, 8? Yes. Giant 1. Answer is x over 2. Okay, exclusions, taking a look at this, it looks like x cannot be negative 4. And I can actually tell easier in the factored form. Okay guys, I hope that was helpful. We'll talk to you again soon for 15 to 17. Have a great day.